Today's in this class we have to solve the exercise number 1.1 and this is question number 2. Okay, in last class you already solved the question number 1 of the exercise number 1.5. See here, this is first second question. Simplify each of the following expression. Means these equation now have to simplify. Okay, see here, in the bracket 3 plus root 3 bracket complete, in the bracket 2 plus root 2 bracket complete, which means these two terms, this set of two terms is multiplied by this set of two terms. Is it right? So first now we have to multiply single terms, means 3 into 2 and 3 into root 2 plus root 3 into 2 and root 3 into root 2. Is it right? See here, 3 into 2, 3 into 2 plus 3 into 2 plus 3 into root 2, which means 3 root 2. Is it right? Next plus root 3 into 2, which means 2 root 3. Is it right? Next plus root 3 into root 2, root 3 into root 2. Is it right? See here, 3 2s are 6 plus 3 root 2 plus 2 root 3 plus now see here, root 2 and root 3 we can't add each other. Is it right? These two terms are separate, so that's why we have to write as it is. Is it right? Next plus, see here, in the case of operation, in the case of multiple operation, we can multiply these both numbers in roots, which means here, see here, so root a into root b is equal to the square root of a into b. Is it right? So that's why we have to multiply these two terms, means the square root of 3 into 2 means 3 2s are 6. 3 2s are 6. Is it right? Next, see here, root 3 into root 2, which means root 6. Is it right? This is your answer. This is next question. Okay, question number 2. See here, okay, 3 plus root 3, first bracket, in second bracket 3 minus root 3, which means it is in the form of a plus b, in the bracket a plus b into in the bracket a minus b. Okay, then what is the identity source for this equation? Yes, a plus b into a minus b is equal to a square minus b square. Is it right? This is one identity. Is it right? See here. Now a value is 3 and b value is root 3, which means a square minus b square. Means here 3 square minus the square root of 3 square. Right? So 3 into 3 9 minus, now square root, square and square root get cancelled. Okay, the remaining term is 3, which means 9 minus 3. 9 minus 3, 6. Right? This is your answer. Okay. Now see here, question number 3. Root 5 plus root 2 whole square, which means here, which identity suits here? A plus b whole square. Is it right? A plus b whole square. So consider the value of a is root 5 and the value of b is root 2. A plus b whole square is equal to a square plus b square plus 2ab. Is it right? So now we have to put these values in that equation. Okay. Then automatically you can solve this equation. Okay. This is your homework. Okay. Okay. You can solve by using this identity in your home. Okay. See here. This is also similarly to the question number 2. Okay, it is exactly similar to the question number 2. Why? See here. This is a minus b into a plus b is equal to a square minus b square. Is it right? So see here, a square means 5 square root of 5 whole square minus square root of 2 whole square. So square and square root get cancelled, square and square root get cancelled. The remaining is 5 minus 2 is equal to 3. 5 minus 2 is equal to 3. Or you can write like this. Okay. 5 minus 2 is equal to 3. This is your answer. Okay. Now the question number 3 is your homework. Okay. So now we have discussed about the question number 3 in the exercise number 1.5. Okay. See here, this is question number 3. Okay. First we have to read. They say recall, which means you already know about the value of pi. Okay, you already know about the concept of pi in your previous classes. Okay, so that's why you can recall pi is defined as the ratio of circumference. Okay, the circumference can you say c? Yes. Okay, the circumference you can say c of a circle to its diameter. You can say diameter is equal to d. That is, the pi is equal to circumference divided by d. Okay, this is one circle. Okay, this is one circle and this is diameter. Okay, diameter d and this is circumference of this circle. Okay, c. Now this seems to contradict the fact that pi is irrational. How will you resolve this contradiction? Yes, you already know the value of pi. Is it right? So therefore here pi is equal to c divided by d and the value of pi is equal to 22 divided by 7. Okay. After you solving the 22 divided by 2, the quotient you get 1%. Okay, that quotient is non-terminating, non-repeating decimal expansion. Is it right? So is equal to non-terminating. Okay, non-terminating as well as non-repeating. Non-terminating and non-repeating decimal expansion. Is it right? Non-terminating, non-repeating decimal expansion. So that's why the pi is an irrational number. Is it right? So pi is an irrational number. Is it right? So please note down this and we shall stop here. Okay. In the next class, we have to solve the question number 5. Okay, in exercise number 1.5. I hope you understood this concept. Okay, see here. Recall means, which means the pi is defined as, you already know the idea of or the concept of pi. Pi is equal to circumference divided by d in a circle or of a circle. See here, this is this one circle and this is the diameter and this is the circumference of this circle. Okay, circumference divided by d is equal to pi. Okay, and the particular one fixed value of pi is there. Okay, which value it is? 22 divided by 7. So 22 is circumference of the circle and 7 is the diameter of circle. Okay, next after solving the 22 divided by 7, your quotient will be non-terminating, non-repeating decimal expansion. Okay, and you know that the non-terminating, non-repeating decimal expansion is a irrational number. Is it right? Please note down this. Okay, so start. Thank you.